you, Muji, start off with.
That's my value add here.
It is.
Quite
It
frankly,
is. You do.
I did this for let's say 20 years. Let's round down.
Sure.
And I've done software development from web software, Windows applications to web, to distributed applications, to complex architectures with multiple tiers. And so I've just been designing this, been in and around application development, been in and around data, been in and around network security tangentially. So I just, as an engineer, I understand these things, and I somewhere along the line got good at boiling things down. So,
well, that's
hopefully that whirlwind through application development and the ecosystem of companies was helpful.
Absolutely. I think when you can boil it down and make it understandable is when you truly understand it. And all that experience is paying off. So, Muji, the first question that we have here that came in from Joseph is, over time, do you think the cloud service providers will destroy the value proposition offered by these DevOps players as more and more tech becomes automated and available as configuration in the cloud from CSPs, especially as low and no code solutions also become more prevalent?
Wow, there's a lot there, and fantastic question. Greatly appreciate it, because I definitely cut the no code, low code part of my talk. In answer to your question, no, I do not feel that the cloud providers are going to eradicate the need for these DevOps tools because of that opinionated view and the variety of things. But let's be clear, for a company like GitLab, the prime competitors are the cloud providers. They all have CI/CD pipelines. They all have deployment techniques. They all have platform as a service where you can erase infrastructural concerns and just deploy applications serverlessly. They have serverless functions. So they're starting to erase a lot of the infrastructural concerns at that layer, but you still have all of the tools to run your processes as needed, all of the SaaS applications and other platforms as a service, other edge networks that are emerging. I don't think the clouds are ever going to do it all. What they want to do is it's kind of do the most common things, all geared for their own individual platforms. So a CI/CD pipeline just for Amazon in their code pipeline. Azure has that. Google Cloud Platform has that. So these companies are succeeding in this market, growing from 30 to 70%, as you just saw, despite the fact that those clouds all have those tools. And so I don't see the clouds being a particular threat here. As far as the low code, no code, what low code, no code is doing is expanding the audience. And I think that's going to help solve some of the talent shortages. It's hard to find a good developer, especially security is especially hard to find talent, because that's just exploding in interest right now. But what no code, low code tools are providing is for non-developers to do some of these things, like stitch together two different applications, create automated workflows. Those are interesting tools like Monday, Asana, Atlassian is moving this direction. Those workflow management tools are interesting use of no code, low code. As a developer, as a coder, no code, low code isn't there yet. I think because you have the power of customizing your code exactly the way you want, you don't want to be constrained by tools like that. And so to me, it's expanding the audience.
Oh, that makes a lot of sense. And on the same theme of where the industry is going, Mohsin wants to know, do you see consolidation in the space? In 10 years, do you see platforms such as Atlassian being dominant, or vertical specialists, i.e. PagerDuty, etc., getting stronger, or coexist as they do today?
Great question. Yes, I see the platforms getting bigger. And that's why I'm actually interested in this space. The bundle play that's happening here. GitLab is a great example of this. They're able to create a CI/CD pipeline, have an ambitious plan to fill in tooling around all the stages within that pipeline through their own development efforts, through leveraging other open source tools to be that bundled play. And so the bundles are going to win here. Whoever has the developer eyes all day long. GitLab has the developer eyes all day long. The CI/CD pipelines have the developer eyes all day long. So GitLab, JFrog are competing on that. Datadog has the developer eyes all day long on production stacks. They're monitoring stacks, seeing what's happening, monitoring their code performance. And so, these things are all merging in the middle between those two separate areas, much less you have Atlassian that's creating collaboration tools. It seems to be staying in its lane a little more than the others, and I don't see it necessarily colliding. It excels at team collaboration and is exploiting that on the edges of the DevOps workflow. I think there's room for a lot of these companies to succeed because of this bundle play and start eliminating open source tooling. It is, probably the biggest threat here is new tools are emerging all the time. As companies want to adopt those, these platforms need to provide a better solution. So having that unified view over the entirety of your enterprise, every single development team can be viewed through these platforms. That's what has appeal for the larger companies that are bringing current success to the companies mentioned.
That's a great lead into our next question from Felipe, which is, and I'm going to stoke the fire a little bit here because Neil also asked a question very related. So Felipe asks, I saw that Cloudflare recently open sourced Workers. Thoughts on some of the reasons and what impact this might have? And related, Neil asks, and something you and I have talked a lot about in the past is Cloudflare versus Fastly. Can you elaborate on the difference between the two?
I'm not sure I want to step on that landmine. Or at least it was a landmine last year, not so much this year, now that Fastly is not done well in the market, shall we say. With Cloudflare Workers, I mentioned on one of the slides, new developer ecosystems that are emerging. Cloudflare Workers is one of them, which is a serverless function environment where you can distribute your application, including API endpoints, around the globe into 250 locations at once. And so that reduces the latency and basically creates a mesh around the globe for your application deployment where it can be everywhere at once. And so it's a different sort of application environment. You're not going to do heavy compute actions there, probably not store a lot of heavy data there, certainly not doing machine learning training or data warehousing at the edge. All of that is more ideal for centralized cloud. But it's providing a new front in application deployment that we're just seeing the beginnings of. Netlify, Vercel, Bun is a brand new startup that just got funded that are creating new JavaScript and Node environments for web application development. That's what Workers Runtime is all about, and is why they're making it open source, is so that it can they want to compete in that space with the other providers. You look at a company like Vercel, they have an opinion about how applications should be developed with their Next.js, and all of these kind of front-end application stacks that are distributed in edge networks are starting to add more full stack capabilities where they can do more logic and API calls. And that's really opening the door to them becoming a viable place to build an entire business at this point. As you saw cloud native businesses, you're going to start seeing edge native businesses emerge on these platforms. And so, the open source is one step into their primary focus right now, Cloudflare's primary focus, which is adoption. They're stressing adoption. They want to get eyes on Workers in order for them to build more and more primitives on it, as the clouds did. Once you had the raw IaaS, raw infrastructure in clouds, they started building abstraction layers on top of it to utilize these tools to provide more databases, streaming services, etc. That's what Cloudflare is doing with Workers. It wants the adoption now. It's going to leverage that adoption with the abstraction layers that are coming. And they're providing other ways outside of Workers to build applications with streaming interfaces for video and audio. And so there are other tools that are emerging from that ecosystem too.
Absolutely. And you kind of mentioned, Cloudflare wants many eyeballs on Workers, on the Cloudflare ecosystem as many eyeballs as possible. It kind of leads into this next question, which is, how important is the sales motion for these companies? Do you prefer product-led or sales-led, bottom-up or top-down?
That's a harder question because it's all over the place for these companies. There's no one answer here. I guess I'll say, as they bundle more and more, as they become a more unified platform, like GitLab, JFrog are doing, even ServiceNow is a competitor with both of those companies because they have a CI/CD pipeline management tool as well, much less those other two companies are getting into incident management, which is ServiceNow's forte. And so it's these companies are becoming bundled plays to eliminate the point products. As a kind of a result of that, they're becoming a more top-down decision. And that's where you start getting into the value stream management systems that I was talking about, where an enterprise says, hey, we've got all these disparate development efforts going on. We've got a team here. We've got a team in Europe doing this other thing. We've got a team in Japan doing something else. And we want a unified view over it. That's where these bundled platforms are going to have a lot of success, is into selling to more larger global enterprises, more modern, cloud native enterprises that have a lot of distributed teams, because it gives a unified view over them. So I think these tools are absolutely traditionally bottom up. It's the developer teams themselves deciding which tools to adopt. That's starting to move into kind of the immediate management to make that decision, the head of development. But now it's moving up further into the C-suite to say, hey, we need to tie business value to these things. We're a software company, and we need to directly monitor the progress of our development efforts and then tie it into business value. And so I think it's absolutely moving from bottom up to top down. And it's important, I think, for these companies to maintain both motions. They shouldn't go all in one direction, because they need that groundswell of adoption, like we just talked about Cloudflare Workers, to even get interest in these platforms from the developers themselves to be the person advocating for it in an organization. But ultimately, they need to also sell top down to say our platform is for the entire enterprise.
Right. And I think it's something that Peter talked about yesterday, which is by selling top down, you then have the ability to expand further within the organization just from a top down directive. And you see a lot of these companies talk about it during the earnings calls, kind of pivoting that sales motion, especially as the cost of the budget increases are moving higher and higher up as companies are more and more cognizant of those costs in this environment, at least. So Muji, I want to keep going, but guys, I know there's a lot of questions that have come in from Muji, and we have to wrap up the session now. But feel free to reach out to him on his Twitter, email him, whatever it may be, because there's no way I can get to all these questions now, and we have to ask our last question that we've been asking everybody, which is, Muji, if there's one piece of investment advice that you can give to individual retail investors, what would it be?
Well, my stock answer is always time. Time as a retail investor is your advantage. And so, I'm a person who likes to understand the technology, understand the underlying trends, understand where a company likes to go next. And so, these things take time, and, any one quarter's performance, I like to have the longer term view over some of these companies. And so that's the greatest advantage I feel like any retail investor has. Although another answer I've given is very similar to Peter's answer yesterday, which was write it down. I am an extreme note taker. I highly recommend tools like Evernote, Roam. I use a tool called Obsidian to create my own personal wiki of information where I can cross-reference stuff. That's helpful from an investment standpoint. It's helpful from a technology research standpoint. And so I highly recommend note-taking as well.
There we go. Note-taking, a common theme, and also time. Two common themes we've had in this conference so far. Well, Muji, thank you so much.
Nothing new for me, I guess.
I think the presentation was pretty new for a lot of people. Well, Muji, thanks again so much. We really appreciate it as always. We loved having you back this year. I think everybody, as I did, learned a lot again.
Thank you.
And everybody, you can join us in about 15 minutes for our final session for the summit, which is going to be about commercializing AI. Thank you to Titan and ARC for sponsoring this session, and we will see you all in a few minutes.
One last note: if there's that many Q&A questions, I'll if you're going to stick around and have a room after, I'm happy to.
Let's do a networking room. That'd be great.
So
awesome. So for everyone who asked those questions, just stick around after the next session, and we'll do a networking room with Muji. That'd be great.
Excellent.
Thanks, everyone.
Thank you.
Are you ready to invest in venture capital? Welcome to the ARC Venture Fund, exclusively on Titan. You'll have your capital invested in some of the most disruptive and innovative companies operating today. From seed stage upstarts to publicly listed giants. Let's get started. Are you ready to invest in?
This is going to be a presentation on general AI and the path to commercialization. I'm not going to introduce speakers. I'm going to let them introduce themselves because we have a panel of 3 of them. So guys, take it away.
Awesome. Thanks so much, Chris and Deval. So we are going to be talking about AI. I'm sure you guys have heard a lot of the recent exciting updates in AI, especially in 2020, 2021, 2022. And this is a super, exciting topic. I'm super passionate about it. Mo and Liam are both in the space, and they're also super passionate about it. And we think we're really at basically like a turning point, potentially, where this thing is, potentially we're kind of at that inflection point, going from everything being specific to potentially, general AI having a future forward. A little note about this astronaut image. She was generated by DALL-E. And I'm sure Mo has a lot of comments on it, but it was kind of the first female astronaut kind of image generated by computer that ended up on Cosmopolitan. So basically kind of along the theme of, general AI, something that's super like what the public perceives as super complex, kind of going into mass market mainstream. And with that, I'll let Liam and Mo first themselves.
Hey everybody, I'm Lee Marie. I'm a principal at Founders Fund right now. I've been at Founders Fund about 1.5 years. Tend to focus on our enterprise software investing across all stages, with a particular focus on machine learning, infra, and applications. Prior to Founders Fund, I was one of the first engineers at Scale AI, a machine learning startup, which we'll get more into later. And then I was a product manager there. At Scale, I worked with a ton of ML engineers, both externally, it was the main customer that we were serving, and then internally, building models to improve unit economics. And then prior to Scale, I studied ML in college, so kind of, a combination of math, computer science, and a bit of magic that I really loved, and then knew I wanted to work on that coming out of school.
Ming, you can go next. We'll go in the order of the slides.
Okay, good. Cool. So I am out of the 3 of us, I am the furthest away from AI. I, like Lemur, also studied, took a couple of ML classes in school, in undergrad, left, and I went to go work on Wall Street. So previously was an investment analyst at Point72, and then left that, came to Silicon Valley. And of course, once I was in Silicon Valley, it was kind of, AI was everywhere. Every startup was an application on top of AI, building on top of CNNs, which we'll get into. I came to SF back in 2017, and I think back then it was kind of like AlphaGo had just kind of like taken off and gone mainstream. ImageNet had gone mainstream, and so ever since then, this has been a topic that I've been super passionate about.
My name is Mohammed Bovarian, and I've been a research scientist working on large language models for 2 years at the General Artificial Intelligence Laboratory called OpenAI, based in San Francisco also. So all 3 of us are based in here. And the diversity here, like research scientists, venture capitalists, and finance experts, all talking about and passionate about AI. Interestingly, if you go 6-7 years back, AI was not as, it was more of an academic topic. And this has been a change that actually we will talk about in the coming slides as well. And given the fact that I've been at OpenAI as an AI researcher, I'll be the one giving the history lessons here. I'll try to also touch upon my own personal touches as I tell you about the history of AI a little bit, and how we came to this point in 2022 that clearly things have changed, like the amount of investment, the amount of public excitement. You would have John Oliver talking about AI in his show. This wouldn't have happened about any academic subjects a couple of years ago. So we know that this is an important point in history. So before that, let me try to discuss a bit of terminology. So most of you are familiar with the terminology AI and artificial intelligence, and there is a related word called machine learning, which is commonly, almost interchangeably used in the public. And maybe it's good to even discuss what's the difference and why is there even a difference? Like if they're discussed so interchangeably, is there any like what's the why do we have even two terms? And the basic idea is that AI is a more general outcome-based definition. AI means replicating human intelligence or highest form of intelligence, could be even bigger than humans, using computers, artificial methods. We want to create a form of intelligence that is even beyond our own abilities. What is ML? ML is a more approach-based thing. ML means like we can learn from data. And it's like saying that by looking at data, you can and looking at the patterns of data, you can replicate intelligence. A basic way of looking at, a good way of like looking at this is by going to the slide, the first example here, translation. Suppose you want to solve translation. You want to create a system that translates from any language to any other language perfectly. As you can see, that can be a hugely valuable business. Even Google right now, even though it's pretty great, doesn't do it for every single pair of languages. So even if this is the historically first examples of widely used AI, this is still not completely solved. So you can have two ways of approaching this problem. You can say, I'm just going to compose all the rules for translating from, say, French to English. Like, je goes to I, manger goes to eat, and like stuff like that. You can try to compose all the rules there possibly is and a dictionary and say, I'm going to write a 1,000 line, 10,000 line program that translates French to English. As you go and try this, very quickly you will realize the number of exceptions and number of subtleties in language are just so enormous that any approach like that would absolutely fail. And that goes back to actually the history of AI, because in fact, even though AI seems like has recently become something mainstream, actually there were two big AI revolutions prior to the current revolution that there was huge booms and then busts, huge booms and then busts. And this is the third AI revolution. And when it was happening, actually a lot of people were afraid that this is going to be yet another boom and bust. And I'm going to tell you that so far all indication is this is the one, and this is the one that is changing the course of history for us. But going back to the slides, now that the general historical lesson is done, is even though AI more looked like a recent phenomenon, there were snippets of it all over across the past 20, 30 years, from the deep blue, the chess things that were in one of the previous AI revolutions, which didn't translate to applications, to ranking in Google, autocorrect, translation, autocomplete. There were a surge of chatbots 5-6 years ago that didn't go very well, and then and as we shall see, there is a recent surge that we all expect that it will be much more fruitful to this day, where things like GPT-3, DALL-E, Copilot, Codex has become more mainstream. Next slide.
And Mo, if you actually want to give the audience like a brief description of what like GPT-3 and the latest language models are, and what is the significance? How are they like different than like previous language models?
Yeah. I'll give a brief description, but let's go to the next slide. I'll start from the the beginning. So the recent modern surge in AI arguably started from this paper called ImageNet by Jeff Hinton, Elias Discover, and Alex Kurvitsky. And that was the beginning of around 2009. That was the beginning. And I actually remember this a year after at MIT, we were all discussing this. And at that point, everybody was like, is it real? Is it not? And how things will go. And basically, we are all very surprised of it. Like, it just accelerated and accelerated and accelerated. And that, at that stage, AI, the recent modern surge of AI, was very much based on classification tasks. Like, given an image, is it a cat or a dog, or what kind of a cat or what kind of a dog? Is it tree? Is it a car? Stuff like this. This classification tasks that were very important, and variants of it, like bounding boxes around objects and stuff like this. Then there was things like GANs that came out, but the thing that was really changed everything again was the introduction of transformers, which is a new architecture, came out around 2017, I believe. And then what followed then was all of these modern things like GPT-3, DALL-E, and Copilot and Codex. GPT-3 probably is the most famous of these. Is a large language model trained around 2020 by OpenAI, and it was one of the first examples where you would talk to a machine learning model. You would write a sentence, like write an essay about the gold system versus Federal Reserve system of monetary supply of currency, and it will write you a pretty reasonable essay. And everybody was looking at this and it's like, I used to do this as a student in high school. So if it can start doing this, so what's gonna, like, next thing you know, it's gonna do my job, which if it can do what I did as a 16-year-old, it probably can do stuff that I do as a 25-year-old or a 30-year-old. So that was basically one of the first moment that things started going mainstream, I would say. GANs took people's imagination, but really people didn't end up knowing how to commercialize it very well. GPT-3, and especially the code version of GPT-3, I argue that Copilot is the first mainstream modern AI application that has actually gone mainstream and is useful for people day to day. People who don't care about fanciness, don't care about, they just want to get their job done. Software engineer wants to get his job done or her job done, and is becoming more productive using this system. And more recently, again, is DALL-E and a Stable Diffusion that maybe Ming and Lee Marie will touch upon in the subsequent slides, which has, in this year, has really captured people's imagination, and we are all excited to see what will come out of them. So, and so I think during the talk we will talk about the different companies and different markets that were important to doing all of these developments that I described. And I think probably Scale, which Lee Marie will discuss, is one of the most important companies that has basically captured the most amount of value. I haven't worked at Scale, so I have no idea, but given the success, it's very clear. Has been one of the biggest winner, and Lee Marie will discuss it.
Thanks, Mo. So I prior to Founders Fund, I was one of the first engineers at Scale. I started there in 2017, and I thought it might be kind of cool to discuss sort of the origin story of Scale and how Scale evolved as an example of one of the AI startups that more people tend to know about, and also as an example of a place where a lot of people, myself included when I started, thought that Scale's initial product was very niche, and the market size was not well understood, just because ML is so nascent, and so all the different parts of what you need to build an ML model, it's hard to kind of understand, how much money people are spending on them. But yeah, so kind of the story here, back in 2017, Scale was offering an API for microtask. So you could essentially, in a self-service fashion, you could request from Scale to get any sort of small task done, whether it was making a phone call, transcribing a receipt, classifying an image, what type of clothing is this from an e-commerce website. And ultimately what we noticed pretty early on was sort of the differentiation from Mechanical Turk and other sorts of task platforms would be that we would fully manage it. So you just send us the data that you need for us to do the task, and we sort of ensure quality, route taskers across the group of sort of freelance taskers that we have around the world, make sure that those people are trained, and then make sure that they're compensated fairly. And sort of early on, we noticed that the one area where this API was getting a lot of traction was among autonomous vehicle companies. So a lot of autonomous vehicle startups were using the API to send images. So maybe going into a little bit more depth there, AV companies need to train something called a perception model. And that essentially is a machine learning model that teaches the car how to behave in the world. Like what are its surroundings? So it needs to know like where a pedestrian is to avoid it, or where the road is to drive on it. So essentially a lot of these AV companies were sending us images and wanting us to label them. And it was incredible, just the volume that we were getting, even without sort of focusing on that particular product. And so ultimately Scale decided to make the first product in the focus autonomous vehicle image labeling. And kind of at the time, a lot of people thought that was an extremely niche market. Turns out a lot of self-driving car startups and larger companies, it is a sizable line item for them. And this little the graphic here shows just exactly sort of how challenging the product of image annotation is to build. You might think it's quite easy. You just kind of build a labeling interface. You're drawing some boxes on an image, and then you're done. That's a vast oversimplification. Essentially, you're managing thousands of people around the world. So you need both quality control infrastructure, routing infrastructure, and then also to keep unit economics favorable, especially in somewhat of a competitive space, you need a lot of automation. So you need machine learning models that are working alongside the humans to label these tasks effectively. So yeah, that kind of is a good graphic to show all the different parts of an image labeling product. And then one insight that we got while we were working with customers on this was the prevalence of LiDAR annotation as well. So LiDAR is a 3D sensor that self-driving car companies use to better understand the world around them in addition to images. Most AV companies have said that LiDAR is vital as a second source of data, especially when cars are driving in the dark or in rain, things like that. So essentially no labeling provider at the time offered the solution. Scale built something, and that also kind of took off very quickly. And then another part of this, and I think this is kind of useful to think about when you're looking at other machine learning startups, labeling data is something that no ML engineer wants to do. An ML engineer sort of studies how to train models effectively, how to deploy models effectively. Labeling the data is essentially something that's very orthogonal to their skill set and their interest. And so a lot of people didn't mind outsourcing this to a third-party company. And ultimately, Scale used image and LiDAR labeling to become a wedge to offer a variety of ML products. So the first kind of pure software product, to my knowledge, was Nucleus, which is a data set management product. Essentially, you can view all your data on Scale, figure out where your data set is deficient, and send things to Scale to make sure that you have a balanced data set for training your perception models. And then over time, Scale continued to expand across different types of customers that are doing language models, things like that. And in some cases, customers that don't have super large ML teams and want more of an end-to-end solution, so providing the model entirely. And so yeah, that's kind of maybe the quick overview of how Scale has evolved over the years, and is now pretty big ML startup.
Cool. So to kind of like step it back, we kind of dived into one specific company, and obviously, most people here have probably heard of Scale at this point, one of the largest unicorns in Silicon Valley. But kind of just to dial it back and look at the big picture, funding has definitely increased significantly. As Mo mentioned earlier, we're kind of in this third heat wave or third wave of post winter, and now in summer of AI development. Lots of exciting things happening, from image generation to kind of like full scale automation of very menial tasks that for instance, like writing the essays that we all wrote when we were in 5th grade, et cetera. And obviously, VC or the amount of VC funding going into AI is obviously reflective of this. Whether that's cause or effect is maybe a debate for another time. But as you can see, AI funding up 108% in 2021, and 2022 not yet over, but you can imagine very similar rise over 2021 as well. And okay, so far, Mo walked us through a little bit of the history of AI, and then we dove deeper into one particular company, Scale. And then if we zoom out, so where does Scale fit in kind of this map? Or like when you think about AI and all of the different companies that can basically reasonably call themselves AI, like what does the kind of the entire industry look like? Is everybody AI kind of the same way like everybody's been crypto or in 2022? Like what does that mean exactly? So the way I like to conceptualize it, and everyone will have their different ways of classification or classifying the industry, but the way I think, from the perspective of a fundamental analyst, I think, okay, so first there's like the providers or like the raw material providers, and in the AI space that means the hardware. So I know the text is a little bit small, but kind of on the bottom here, the hardware manufacturers all the way from NVIDIA, AMD making chips, all the way to infra hardware from AWS, et cetera. And then you can even go as far as the light bulbs from ASML that then power Intel and the others. You can go kind of like infinitely deep into the semiconductor space, but essentially they are who I think are like the bottom pillar of everything. And then everything that sits on top of them, I like to divide into data, modeling, or model R&D, model deployment, and applications. And there's actually another one that I think of conceptually, basically the distribution layer. But I didn't include it here because, frankly speaking, the companies are kind of boring. Like think of your like McKinsey's and Accentures. No offense to McKinsey's and Accentures, or if you currently work there, but I feel like I kind of felt a little bit bad putting the distribution layer, i.e. the McKinsey's and Accentures, next to these ML companies. But but anyhow, so Scale obviously belongs in the data layer, and Scale's various products from labeling to the data set management, et cetera. They're all kind of like sub verticals within data. I like to think of data as, obviously large language models and all the other different types of ML models. The core of it is still the data. So if you want to be able to say like, yeah, like that's a corgi, that's not a German Shepherd, what you need to do is basically feed the models a bunch of, corgis and German Shepherds. And so everything involved in data then like funnels into model R&D, where I would basically put something like OpenAI in model R&D. And then model deployment, I think of more as kind of like all of the DevOps and infra associated with actually taking like the hard part of the model, i.e. the ability to make decisions, and making it something that you can then incorporate into large scale like enterprise tech companies. And then the application layer I think of as basically, if you think of like you have this model, okay, cool, but like a bank is going to use this model very differently than a marketing company. So like previously my work, like I used to be in investment banking, had a lot of, really mundane Excel tasks, from pulling down, as I'm sure a lot of you guys in the audience know, like 10Ks, like digging through 10Ks, looking through footnotes, putting their like 10Q report, their income statement from 2012 next to, Q1 2012, next to Q2 2012, next to Q3, and then, oh, oops, they changed the name from revenue to sales in 2014, and you need to then align it in Excel, and oh, they changed extraordinary items into one-time items and restructuring costs in 2016, and so you need to then realign everything again, and all of that. And basically the domain specific applications, at least today, are very much, like industry by industry. The data is different. All of the learnings that the model has performed have been very bespoke to a specific industry. And so hence this layer, the application layer, I would say, is the most most various, or the most, has the greatest abundance of companies in this area, each one attacking its own vertical. All right. So we're going to zoom in to the model R&D, i.e. the green here. Next. And this was taken
Awesome.
directly Lemur's blog, which you guys should all check out.
Thanks for thanks for the endorsement. Yeah, no. So I wrote a blog post, kind of expanding on opportunities for startups, or types of startups that I'm looking for as an ML infrastructure investor. I guess one thing to note, maybe before we dive into the slide, is that because ML is so new, like Mo's timeline at the beginning of the presentation, those are not far away dates, 10 years ago. It's sort of important milestones in deep learning. So there's not a lot of consensus on what like the ML R&D stack looks like. Most companies do something slightly different, and most companies change their how their stacks look very often. So I think that provides a big opportunity for startups, but then at the same time, it means that there's a lot of different startups for each particular part of the stack. So maybe let's kind of refresh ourselves on the model lifecycle. So we already talked about data collection and annotation, Scale being a provider in that space. But after you get the data, you need to train your model, and then you need to test it, and then sort of debug it to make sure it's ready for production deployment. And then, some people believe you need to monitor the model to make sure if there's new data or, like some sort of information you need to act on, the model updates very quickly. So the canonical example here is, you're Amazon, and then there's some, thing that goes viral, and you need to be able to surface new search results very quickly because of some new viral product. So the opportunities that I kind of touched upon in the blog post for where new potential ML companies could come from, I think in terms of the core workflow, so this is the orange box on the right side, there is not a lot of consensus when it comes to like what is the best, fastest, cheapest way to do something. So whether it's using a model API out of the box, or using a set of developer tools to make your own model, not a ton of consensus. And so therefore there are multiple startups in each of those spaces. And there's always this question of sort of building versus buying. If you have one ML engineer on your team, do you try to build your own model deployment yourself, or do you outsource it to one of these API providers? That's still a question. And then another thing to note, when you're training a machine learning model and putting it into production, there's a lot of communication that's required across different stakeholders. So, you might think, well, you have the ML engineer, they can kind of do it all themselves. Typically, they're working with, infrastructure engineers for the deployment, especially if it's, a real-time production use case, because those are sort of different skills required. Then you can train a model really well, but can you serve it at low latency? It's just a different set of skills. So you need to work with an engineer, and then you might need to work with sort of product stakeholders, because ultimately this model is being used in the product. And so it needs to accomplish business goals, and you'll probably need to collaborate with product engineers, if not product managers or other people at the company. And then there's this whole set of sort of opportunities around making things more reliable. So right now, and I've experienced this myself both as an engineer and as a product manager. There's not a ton of consensus in terms of how to make sure that your model is very reliable before you put it in production. So whether it's proactively stress testing the model on a set of cases that either you or an external provider develops, or sort of creating monitoring for it in production. And then lastly, so there's another sort of category, and we haven't talked a ton about this, but not only can you collect data in the real world, but also some people, and it's becoming more of a consensus, think that you can create data automatically. So basically augmenting your real world data, changing it in certain ways to basically get more bang for your buck when it comes to data collection. So this is commonly referred to as synthetic data. So whether it's creating sort of transformations of your existing data, or completely starting from a blank slate and in a sort of Pixar style way, creating different worlds to capture edge cases that are hard to find in the real world. And then separately, there's actually a whole class of companies also around, like, how do you take sensitive data and make it appropriate to train in production without violating any sort of privacy concerns. And then, the kind of the last section is a little bit orthogonal to the other things that we've talked about. But, let's say you're a company and you don't have any ML engineers. How do you sort of get the value out of ML? And this is more in the application layer. So companies that essentially offer specific things that ML is good at for you. So for example, if you want to use ML to predict churn or forecasting, companies that will plug into your sort of data stack and do the end-to-end machine learning experience for you. Starting to see more and more of those. And then this is the kind of other part of Ming's original slide. And this is focusing on large language models. So this is really just kind of expanding on the potential for these models and all that they can do, whether it's complete automation or assisting humans. But and this is stuff that already works, which is just like mind blowing to me. Like my sort of light bulb moment was seeing these models actually perform well in these sorts of tasks. Namely, my mind was blown with the sort of code gen section. Just like seeing models being able to write code, which is like one of the things that I would have bet years ago that they would just never be able to do, or it would be really, really hard for them to do. So yeah, maybe double clicking on the slide a bit. So in this sort of natural language sector, there's sort of these social agents, these sort of next gen chatbots. There's sort of developer focused like text applications. Essentially, like if you want to integrate a like sentiment analysis into your product or something like that, you can use these companies. Knowledge management, writing, so think copywriting, automatic generation of different types of content, search, sort of the next evolution of different types of search, whether it's enterprise or sort of consumer search. And then let's see, maybe zooming out a little bit. No, I think we zoomed. I mean, can you zoom out a little? Yeah, awesome, thank you. And then there's this whole section on sort of like, can you use these models for game development? And sort of, we're actually investors in one of these companies, but in World. But can you essentially like create NPC personalities just with ML? And yeah, it's pretty crazy, but it's working. And then sort of there's other categories, and this maybe gets a little bit out of the large language model, but it's more in sort of generative models, generating new types of images, whether it's for, like marketing or whether it's for just art or fun. And then video, like doing different types of video editing, or like, even going further to generate videos. And then the whole section on like code generation. So being an assistant to programmers, creating documentation automatically, designing apps automatically, which is pretty mind blowing. But yeah, these models are already at a level where they can do or assist people doing all these sorts of things, and really excited to continue to see these applications develop.
cool. So one topic that we often do in industry analysis as a fundamental analyst is we kind of look at who else is in the space. If you zoom in on any one particular vertical, let's say the data vertical or the actions vertical, let's say like applications in finance, like AI companies that are selling inks, hedge funds, pension funds, etc. How do you assess, whether, let's say, a company is doing really well today, how do we assess, its ability to sustainably to preserve its cash flows and revenue, etc. So Porter's five forces, something that super common, at least use as a framework to think about from kind of a fundamental analysis perspective. So I'm going to focus on primarily the application layer. I know enough about like model R&D, definitely not as much as Rowan. So I'm going to focus on the application layer of the stack. And so essentially, I conceive of these companies as as my inputs. I'm going to take in, let's say, like I'm going to build some application on top of Dolly or on top of GPT-3, some models that are either open models that Microsoft can provide or OpenAI will provide via Microsoft, etc. And so I take in these models, I take an input from the real world, i.e. my customer's problem, and I use them to, and then I kind of combine the two, and I use these models to then generate and basically like solve problems for my customers. So one example would be, let's say I'm like a marketing agency that's AI powered, and I have a ton of clients that I'm making PR ads for, and I use GPT-3 on the back end in order to to not have to hire let's say instead of hiring 20 people under my organization, I'm going to just hire 5, and I'm going to have them basically like spell check and like tone check on top of what GPT-3 generates. I'm sure there are tons of marketing agencies very similar to my description here. And so let's just like zoom in on this particular example and analyze, Porter's five forces. So competitive rivalry, how easy is it to, and also that's very related with threat of new entrants. So essentially, how easy is it to basically, have my neighbor Joe down the street say, okay, I'm going to open up an AI powered marketing agency just like you, because GPT-3 access is like pretty cheap now. Like I can get like a pretty like basic version for like $10 a month, let's say. And so Joe, if I can do that, Joe can do that. And so the inputs are, the cost is pretty low, pretty easy. Like all of the researchers at Google Brain, OpenAI, et cetera, have already done all the hard work. I just need to import their models, and I don't even need to use my head really that much. Or at least I certainly don't need to know, any of the math. I just kind of plug and play. And so because of that, I feel like at least at the application layer, a lot of the competitive rivalry is pretty high, and the threat of new entrants is pretty easy for new entrants to pop up. And from the landscape map that that you saw previously, you can tell that there have been there are tons of players in the space. A lot of them have only been around for 1 to 2 years. So definitely heating up and quite competitive now. Bargaining power of suppliers. So again, this kind of depends on where you sit in the stack, but at the application layer, who are the suppliers of these application companies? Basically the modeling companies, or the companies that are providing these models. So companies like an OpenAI, which I would say like they have pretty high bargaining power when there's only a handful of them. Like if there's only 3 to 5 big ones, then the question becomes how easy is it for for a new entrant to basically create like an OpenAI competitor or like a Google Brain competitor and then what are the chances that the suppliers of these application companies are going to become very numerous and competitive themselves, in which case if there's more of them, then that lowers their each of them's bargaining power, because then the application companies can just say like, well, no, I'm not going to use OpenAI's model, I'm just going to use Brains instead, or I'm just going to use Microsoft's model instead. But basically, I think in the current state, it seems like they have pretty good bargaining power, and I feel like they should be able to sustain that for at least a few years. The cost of model training, et cetera, is going down. So I guess that would be a headwind in terms of the R&D companies. And then substitutes. So right now, I think in most applications, kind of the best replacement for these AI models is still a human. So take like a large customer support organization. Essentially, the pitch of these AI companies is, we can cut your labor force down from 100 support agents down to, let's say, 50, down to maybe like 20, because we can basically have the AI triage and decide, and just like submit automatic answers to the simplest customer support questions. And then the more complicated ones, we, filter down and give it to the humans. Essentially, it makes, the workflow and the operations behind these kind of often, like heavily, basically industries with a large human labor base, allows them to basically cut down on that. I don't really see a ton of other, good substitutes for these AI models, because at this point it's kind of like you need to classify, you need to make a prediction, or you get a Gigster or Fiverr or whatnot to do it, or you use a model, or you do it yourself, which is still human labor. And then bargaining power of customers. So I would say a lot. It kind of varies a bit depending on the industry and depending on whether a company is B2B, B2B2C, or B2C. Obviously, if you're looking at a B2C company, I feel like the bargaining power of customers at this point, I would say it's in B2C, it's still pretty high, because the customers don't really know what they want. It's kind of like that expression of, if Henry Ford asked people whether they want, like they would say they want faster horses. We're kind of at this stage where the end consumer is kind of like, yeah, I would like a faster horse, and they're not really able to conceive of, what a car is before the car exists. And so I would say it's still, you still have that, like, because you have that education barrier, the customers don't know what they don't have, and therefore their demand for it isn't as strong as where it should be. And therefore they can still basically say, like, I'm not going to pay $50 a month. I'm only willing to pay $10 a month. And at this stage, it kind of makes sense for the companies to basically, let the consumer have their way, until they start, getting addicted to it and realizing, like, hey, I actually can't survive without these AI assistant tools, etc. But I definitely think, as it becomes more mainstream, people should desire it more. But as it does become, more mainstream, then it's also less, it becomes more like democratized. And then in that sense, the bargaining power of customers will then, also go down. All right, so this is kind of like a hodgepodge. I guess we'll kind of like all chime in here. I can start with headwinds that I see. I'll be the pessimistic one, and we'll let you two talk about more general themes and tailwinds.
Yeah, I mean, we need a skeptic on the panel, right?
I feel like the finance guy is always the one who's like pessimistic about everything. Doesn't get into a trend until it's like way too late. So headwinds that I see, compute cost is still pretty high. So in a way, that's good, because then the current organizations that have already trained and developed the models can use that as a barrier to entry, but also it is a barrier to entry to new entrants, and therefore kind of like the industry as a whole. let's see. So accuracy demands, i.e., like the number of nines problem. So kind of the same way that the consumers are kind of like, oh, like I want a faster horse. I don't know what a car looks like. When you go to enterprise, in especially I would say like maybe like healthcare, the demands are often super high for super high accuracy. Copywriting, marketing, obviously the demands in accuracy and number of nines is a lot lower than, if you're like drug manufacturing. But still a lot of domains, and in fintech too, when there's, a ton of money in the line. Let's take fraud as an example. Like if you're, if you don't catch fraud, if there's like a false negative somewhere in the pipeline that's completely run by machine learning, then that gets very costly because, there's potentially millions or, more than that number of dollars on the line. And then talked about this a little bit in Porter's Five Forces, but basically the kind of general like lack of competitive moat in, or at least what I believe there are, kind of a lack of a moat in a lot of areas of the application stack. Kind of to use my example before, like if I can start, a marketing agency on top of some, AI model that I pull from GitHub, like so can my neighbor and so can his neighbor, et cetera, et cetera. So these are like kind of the biggest headwinds, at least that I see.
So, Louis, do you want to take the tailwind and I get the neutral
Yeah.
one?
I feel like as the VC, I need to be the most optimistic. So yeah, no, that sounds good. So I guess one particular tailwind for some of the like more consumer facing applications we talked about, just sort of rise of gig and creator economies on the internet. Also just like the proliferation of e-commerce and just us doing more and more things online. I mean, obviously at that point it makes it more of a software problem versus software and hardware, which is easier. This one, so abundance of data, I'll caveat this. So there's definitely a lot of data online, and that's how some of these big models got trained so quickly, whether it's like, Codex and all the data on GitHub, or, GPT-3 and all the text all over the internet. I think that can be a tailwind for some applications, but a headwind for others when there isn't data to bootstrap it currently. So for example, let's say that I wanted to create an assistant for a very particular type of software. And I would need sort of like data that shows like, okay, after people click this button in the software, they probably click this button next. So kind of like a co-pilot for different types of software. But data is not readily available. So for me to like create that sort of application, I would need to create that data myself. But then, on the flip side, that actually gives me more of a moat. So there are certain applications where if the data is not as readily accessible, sure, it's harder, but then also potentially a better opportunity to build a business off of data and product.
If I add something here, it's like medical data is one example of this, where it's not hugely available, but it's a great moat. Like if you're solving a certain type of cancer or a rare disease, etc. It's a good example to consider versus the internet data. Yeah.
Totally. That totally makes sense. And then another sort of tailwind, so rise of the semi-technical power user. Essentially, just you don't have to be an ML engineer to use these products. A data scientist might find a ton of value in a sort of ML out of the box churn predictor. And then another tailwind, especially kind of given the current macro, there is continued pressure to automate and assist to cut cost. And so I think if these applications can prove to companies that they are helping them save a ton of money or headcount or time, I do think that that's a really compelling value proposition, and can be more resilient in the upcoming macro.
Yeah. So more like as a general themes of how things will evolve in the next few years, I think one big open question is whether most of the development will happen in like most of the value will accrue in the application layers or like the model providers. And that a lot of the times will come down to whether the open source movement will be the main driver here, or will the companies like OpenAI and Google and DeepMind, which have been so far the most active in passing the torch, taking the torch forward. Will they continue to be the ones or not? And until maybe last 6 months, it looked like these guys gonna be completely dominant. But then there has been surge of, and there has been before, but there has been a recent surge of open source applications that have a lot of momentum and could potentially capture a lot of the and democratize all the values. And that also comes with both pros and cons. You make a powerful model open source, that it also gives rise to a lot of abuse, and some of the enterprises might not be okay with this. But it is definitely an open question that the whole industry is still trying to figure out how, especially in the model case, as Ming was saying, in the model R&D, whether it's going to be open or closed. And the other topic that I want to emphasize as one big open question facing the movement is relatedly is whether these small applications, will they require each of their own model, or there is a world that there are many companies, one of them doing support, one of them doing legal, one of them doing copywriting for marketing, and then the next generations of models come 1 year from then, and there's a general model that just is dominant in all of those three applications over the three. Just like as something's intelligence increases, even with a small amount of data, it will manage to do almost as well as those specialized models in each of those applications. And that's another big question that I think it's fair to say we will find out. We'll figure it out over the next few years. Okay. And yeah, let me as the final slide, let me tell you a little bit about some of the more recent developments in the past year. I already discussed Copilot, which is one of the major code assistance software. This is GitHub Copilot, and then there are. This has been very successful. It basically integrates within your IDE. Where most of the developers code, like VS Code or PyCharm or other JetBrains product. And basically, it's a more intelligent autocomplete system for code that gives you suggestion based on the context. And you can also use it by writing down a comment, like I want a web server here that makes a request to this service. And it usually does a very good job, especially if you're working with an unfamiliar language or part of the code base that you don't understand. Mostly does better than an average developer in that setting. Dolly, GPT-3 we discussed. Stable Diffusion is the most flashiest name in the open source movement right now, I would say. And then Flamingo, I wanted to just point out one that is maybe less familiar to the people. Flamingo is more like a mix of language and image. Be the next few generations of it become big commercial hits. And Whisper, lastly, is an automatic speech recognition system that is released by OpenAI, which is also open source, and it reaches very high levels of accuracy. Most of the time, it's better than me. If I'm listening to a lecture, attending a meeting, YouTube videos, you name it, it can transcribe extremely high accuracy, even rare words usually. And yeah, as you can see, the number of varied applications from coding to describing the lectures, from videos. It's just there's this vast array of things that are all simultaneously being revolutionized right now. Thanks a lot. And with this, I think that's almost the end of the presentation.
Yeah, you guys did awesome. Unfortunately, we only have 5 minutes left for Q&A. So we'll try to get in a few questions if that's all right with you guys. And I'm sure whoever has questions here that I'm not going to be able to get to, reach out to these guys on Twitter, however it may be. And I'm sure they'd be more than happy to answer the questions that you have. I think the first one that maybe we'll start off with is maybe a limitation to AI progress, which could be on the hardware side. So if we're having, parameter counts of these models double every, say, 3.4 months, whatever it may be, but undoubtedly, if you want to say Moore's law, whatever it is, geometry scaling is slowing down for semiconductors, which is powering really everything behind AI and was a delimiting factor, I think, during these crypto windows before. Could that be a hindrance to AI progress near term, long term? How do you guys think about that in terms of getting AI commercialized here?
I can say,
Mo.
I can say a few words. I'm sure Liming and Limery also have their own thoughts. But in my view, the world also has awakened to the potential of these models. So I expect that the hardware will create is a tailwind, but I wouldn't expect it to be the biggest. It's not the biggest headwind, but I expect it to be somewhat of a headwind. And even as you can see, like models like Dolly or the one by Stable Diffusion, they're not that big of models. It's just like there were a lot of algorithmic advances that led to a lot of efficiencies there.
Yeah, I agree with that. I do think there is an opportunity for specialized hardware, but I don't think it's something that's going to be a huge blocker. Just kind of like seeing all the recent advances of just either optimizing algorithms or just throwing more money at it. I think that's one of the reasons why a lot of these companies raise a ton of money, is to kind of get around that. And once there is more generally available specialized hardware that works for particular use cases, we'll just continue to see a proliferation of these models getting trained. But yeah, I don't think it's a huge blocker.
Awesome. So maybe one, yeah, go ahead.
Oh yeah, I was gonna say, I think that there's obviously there's Moore's law, and then there's I think other orthogonal factors that could basically get around Moore's law. I think TPU architecture is basically having designing the chip physically to look like matrix multiplication, and somehow that speeds it up a ton without requiring smaller semiconductor or silicon wafers.
Yeah.
I mean, it's worth noting that all the big tech companies are building their own specialized hardware for this. So and then there's a variety of startups that are trying to bring the same thing to everybody else.
Yeah, they're hiring all the engineers. We can see that pretty clearly. So unfortunately, I don't think I'm going to be able to get to any more questions, since we need to ask our last question that we've been asking everybody during the summit, which is, and we can maybe go from top right to bottom left, which is, if there was one piece of investment advice or some advice generally that you could give to retail or individual investors, what would it be? And maybe Mo, start with you, and then we can go around the horn.
I'll leave it to Limery. I think my investment advice, I want to hear their investment advice and implement it myself rather than give any investment advice at this point.
Well, I guess I have to disclaim this is not Founders Fund speaking. This, any investment advice, it's just things that I'm telling you, not that Founders Fund is saying. Let's see. I mean, I think, I'll just echo a point that we made on a previous slide. Machine learning and AI is a sneakily large market. And yeah, you have to figure out who is actually capturing the value. But things are working and people are spending a lot of money on different parts of it. So, I would not trust, for example, your Gartner or your market map or whatever. I do think that a lot of this data has yet to come to light, and, sort of, make your own judgments about market sizing.
All right, I'm gonna tie this back to ARC's venture fund because I think it I think it totally makes sense, but particularly in the field of AI, which all these companies that we show today, none of them besides Google, Microsoft are public. And so what are the opportunities for regular investors to, financially get in on this movement? There really much choice out there today. And I think, definitely the ARC fund is in exactly that right direction. We're saying with something like that, the average investor access to, like a Cohere or like a Journey, et cetera, any of those, the other companies that, are growing really rapidly. And as long as, there are experts who are doing that due diligence and filtering them, I think it would be awesome. Even me personally, I really want to invest in these companies, but given what's out, it's difficult. And I think that's going to change very quickly with, everything that the ARC fund represents and everything that, collectively here represents. So.
Awesome. I love it. Well, this was a great way to wrap up a full 2 days and 3 full days of the FinTwit Summit. Guys, thank you so much for making us all a lot smarter in terms of what's going on in the AI right now and the opportunity that's lurking out there, especially in the private markets. I want to thank everybody that is tuning in for joining the past 2 days. I hope you got a lot out of it. Don't forget to spread the word about the FinTwit Summit. All proceeds do go to St. Jude. I think it's a great cause. And I hope you all learned a lot this weekend as well. If you want, you can stick around for a networking room with Muji, who's going to elaborate more on the DevOps space that he was talking about in his last session. And once again, thank you so much on behalf of Deval and Rachel, who's been helping a lot in the chat rooms here. I want to thank again Titan and ARC for sponsoring the entire weekend. Thank you all so much for tuning in, and we'll see you guys soon.